Given efficient synthesis of the following compound from benzene, so yet again we have to make something from benzene. Now here again we have to look at the relationships, okay, that we have. So here is an amino group, and amino group is ortho-para director, and here is an aldehyde. Aldehyde is a meta director, okay. An amino group cannot be put in by itself. You actually have to put the nitro group first and then reduce it. Okay, so nitro group first, and then you do the reduction on it in order to get NH2. Okay, and the reduction can be anything. I should not write that. Okay, I can go ahead and just write reduction. There we go, because there are different ways you can do reduction. The aldehyde, on the other hand, can be put by itself, okay, and that is the Karman-Koch synthesis. Now, this relationship is a meta relationship, okay, so which means that I need a meta director first. The other thing about the Karman-Koch synthesis is it involves AlCl3, so which means that I really want to do that one first, so that way I don't have to worry about whether I can do a nitration after putting an aldehyde group and things like that, okay, because you cannot do Friedel-Crafts type of reactions after you have a deactivating group on the benzene ring. Okay, so let's go ahead and do the Gattermann-Koch synthesis first. So which means that you have CO, HCl, AlCl3. This is sort of a Friedel-Crafts reaction, so you have to be careful with it. And so here we have our aldehyde group. And so then the next step will be to do the nitration, because that's how you get an amino group. So HNO3, excuse me. H2SO4. And so then we have the CHO, and now with this group is going to go to the meta position. That's the nitro group. So now we just need to have a reducing agent in order to reduce the nitro group to the amino group. Now here I have to be careful as to what kind of reducing agent I choose, because I have another group that can be reduced. All right, a nitro group can be reduced by two different groups. It can be two different reagents. It can be reduced by LAH, lithium aluminum hydride, or it can also be reduced by a metal using tin. So if I use LAH, it will also reduce the aldehyde. Okay, we did that back in alcohols chapter. But if I use tin and HCl, okay, tin or iron in presence of HCl, now in this case it will only reduce the nitro group. All right, so then I don't have to worry about my aldehyde group. That will be all fine and intact. So here is my NH2 group, and here's my final product then. So again, my relationship is maintained of the meta relationship between the two groups. So the one thing that I had to worry about here was making sure that I don't use a strong reducing agent. So I have to be careful of my groups.